In the next 6 minutes, we'll set up full disk encryption for a Hetzner server with Ubuntu 24. This is also known as encryption at rest and protects your server if somebody tries to physically access your server's disk in the data center, or if the data center throws away an old hard drive and doesn't delete its data properly. We'll be following this excellent tutorial on the Hetzner community website, which uses the Hetzner Rescue System and its installimage script to create a custom partition and encrypted installation. First, we need a server, so we create resource and select servers. We choose any location, any type of server. What we need for this tutorial is an SSH key. In our local machine, we use the SSH keychain command with the -t flag to specify the type and -f to give it a unique name. We leave the passphrase empty for this tutorial. Now that it's generated, we look at it using the cut command and we copy over the public key. In the Hetzner console, we paste it in, save it, and give the server a name such as Encryption at Rest. Create and buy now. Once it's clicked, Hetzner will start provisioning our new cloud server. This should only take a moment, and there it is, our server is up and running. Now for the main part of the tutorial. To modify the disk for encryption, we need to boot into the Hetzner Rescue System. So on our server, we go to Rescue tab and select Enable Rescue and Power Cycle. It's important to select our SSH key from the drop-down menu, because only then we can log into the rescue system using our key afterwards. After we click the button, Hetzner reboots the server into a minimal Linux environment that runs entirely from memory, giving us access to the server's disk. Great! Now the server is in rescue mode and we just connect to it using SSH. I specify the previously generated SSH key using the -i flag, and now we're logged in as root into the Hetzner Rescue System, which is based on Debian. So now step 2 of the tutorial, we need to create a configuration file for the installimage script. This file dictates the entire installation process, and we'll use the nano text editor to create the file at /temp/setup.conf. There we copy in the configuration from the tutorial, and if we review the settings, encrypt password is where we'll set the master password for our encrypted disk. Drive 1 points to our main disk. The part lines define our partitions, one for the EFI boot system, and the second larger partition for our root file system. Notice the crypt keyword at the end of the line. This is what tells the script to encrypt this partition using LUKS, Linux Unified Key Setup. Image specifies the Ubuntu 24 image, and we also change the hostname for anything that just makes sense afterwards, that you understand which one it is. You don't have to have an DNS record pointed to it. And yeah, for the password, choose something strong and secure. Step 3 is about creating the post-install script. When the server boots, the disk is locked, meaning the normal operating system and its network configuration aren't accessible. This script installs a tiny SSH server called Dropbear into the initial boot environment, which will allow us to SSH on a special port to enter our decryption password remotely. Without this, we always need to use the web console. We create a file at /temp/post-install.sh, paste in the script of the tutorial, and make it executable with chmod. Let's do a final check. We need to make sure that we have all these 3 files, which are shown in the tutorial. We had missing the authorized keys file. So we copy the public key that we created before. Create a new file with nano /temp/authorized keys and paste in the public key. It's time to kick off the installation. We'll use the command from step 4, install image. The -a enables automatic mode, -c specifies our config file, and the x points to our post-install script. This gives us a final warning that all data will be erased, but then it proceeds to partition the disk, create the encrypted LUKS container, format the file system, and extract the Ubuntu image. This process will take a few minutes. I will speed it up. And we can see it setting up Dropbear for us now, which is great. So the installation is complete. Now we simply type reboot to reboot the server and into our new encrypted Ubuntu system. But before we can fully boot, we need to unlock it. So remember the Dropbear SSH server that we installed? Now it's running on port 2222. In our local environment, we will SSH to the server's IP again, but this time with port 2222. Now we're in a minimal busybox shell. The prompt tells us what to do, yeah? Run encrypt root unlock. It now asks for the looks password, which we specified before. This is the time to like and subscribe, guys. Awesome. Now the disk is unlocked and the server will continue booting into Ubuntu. Now we can just boot into it over the standard SSH port 22. And once we fix the warnings, which are expected, we can just update the system with get update and upgrade as normal. Now, how do we confirm our encryption is working? We run lsblk to list the blocked devices, and we can clearly see the SDA3 is a cryptolooks type, which is our encrypted partition, and it's mounted as our root file system. Also, you can check with dm setup status script, and it confirms that the looks device is active and shows the cipher use, which is AES. That's it.